Hello guys and girls, today we're looking at parallel and perpendicular lines. Okay, so what I'm going to do is take you through a few questions, and then in a later video I might give you a bit of an intuition as to why it works. Okay, but first of all, just a reminder, parallel lines look like this. They're the ones heading off in the same direction that don't touch. Okay, and perpendicular lines look like that. They intersect, they cross at right angles. Okay, so these are parallel and these are perpendicular. Okay, cool. So the rule is that in the form y equals mx plus b, the lines will have the same gradient, the same number in front of the x. The second rule is that if you times the gradient together in perpendicular lines, you'll get the answer of -1. So if you times that number in the m position together, you'll get an answer of -1. Okay, so let's take you through a few examples. In the first one, we've got y equals -3/2 minus 5, and -3x plus 2y equals 6. Okay, so it's hard to see if these are parallel or perpendicular or anything at the moment. Okay, so what I need to do is put them into the form of y equals, or y equals some number in front of the x plus or minus some other number. Okay, once they're in that form, I can look here and work out if they're parallel or perpendicular. Now, this one is already in that form, so that's fantastic. But this one, the red one, is not. Okay, so my job is going to make that look like the green one, look like the example y equals something x plus or minus something. Okay, so my first job is to get the y by itself, and to do that I add 3x to both sides. Okay, and that gives me 2y equals 3x, the 3x from adding it to both sides, plus the 6 that was already there. Okay, now that's close to this form, but I've still got two lots of y, not one lot of y. So to make it just a y by itself, I divide by 2, do it to the other side to keep it fair, and I end up with y equals 3/2 x plus 6. Okay, so now I've got this side in the form that I wanted, and I can see that its gradient is 3/2, and the gradient of this one is -3/2. And while they look similar in gradient terms, there's a big difference between -3/2 and +3/2, because one's going like that and the other one's going like that. So they're not the same. Okay, so I'll just times them together and see if they equal -1. -3/2 times 3/2. Top times top gives me -9. Bottom times bottom gives me +4. 9/4 is not 1. So these are neither parallel nor perpendicular. They cross, but they're not parallel or perpendicular. Okay, so that's the answer to that one. They intersect. SECT. Okay, they intersect. They do not cross at perpendicular, and they're not parallel. And that's your answer to that question. Okay, question 2. So I'll see if we can keep things steady. Okay, if you look at question 2, it's y equals minus 3x plus 14 and 3x plus y equals minus 1. Okay, and my job, again, I've got this one that looks like the formula, which is really good, but I've got this red one that I need to change to make it look like my target over here, my equation of the line, my y equals something x plus or minus something. Okay, so to change it, all I've got to do is get rid of this 3x on this side, put him on the other side, and then it'll just be y equals something. So I take 3x, and I'm left with y equals minus 3x minus 1. Okay, and now I can see that minus 3x over here is the same as minus 3x over here. So those two are going to be parallel. Okay, and that's my answer. They're parallel because they've got the same gradient. And when I draw them, they should look like that. Okay, like my parallel lines. Okay, finally, I have question 5. Okay, so question 5, again, my first one's in that form that I want, that y equals some number in front of the x, and here it's a fraction, but that's groovy, plus or minus something. Okay, but this second one, again, I need to change to make it look like that sort of form there. So all I do is I take away 5x from both sides, and that gives me 3y equals 24, 5x minus 24, then divided by 3, and I get y equals 5/3 x minus, okay, and I've also got to divide the 24 by 3. So I've got to divide everything by 3 to keep it fair. So 24 divided by 3 is 6. Okay, so now I have them both in the same form. Except, that's why it didn't look right, because I've got to put the minus there. When I took away the 5x from both sides, I needed to have a minus, because I was taking away from 5x from both sides, so it was minus on that side. Hopefully you noticed that mistake before I did. Okay, so next step is to times them together, because minus 5/3 is not the same as 3/5, but minus 5/3 times 3/5. All I'm doing is I'm taking this one, the blue number, and this one, the yellow number, and I'm timesing them together, and I get 5/3, which is top times top, minus 15, bottom times bottom, 15. And that simplifies to -1. So they are perpendicular. Okay, now just to check myself. Okay, I said the first ones were parallel, and if you use Desmos, the graphing calculator, you'll find that they're parallel. Oh, sorry, I said they were nothing, the first ones. Shocking. Okay, so I said they weren't parallel or perpendicular. the minus 3x plus 5. Actually, I'll see if I can get these both on the same screen. Oh, I'll do that later on. Okay, so these ones don't intersect. The parallel ones, the ones with minus 3 and 14, they're parallel. And the perpendicular ones, they're perpendicular. Okay, and just this one's just to show you that this is a really useful tool for checking yourself. Okay, for making sure that you're right. So if you put it into Desmos after you've had a crack at the sort of numbers, then you'll see if you're right. Okay, and you can check yourself. Okay, and that's pretty much parallel and perpendicular lines. Hopefully that was helpful. Bye guys.